Hello, sir. Hello, classmates. Our report is all about motor learning concept and conditions of practice. So let's proceed first in our objective. Number one is what are the theories of motor learning? Second, what is motor learning? And third, how it will be applied on patients. And also our assigned topics. So first, define what is motor learning. Second, theories of motor learning. Third, Fitz and Posner three-stage model, autonomous stage. Lastly, define what is practice condition. So let's proceed that define what is motor learning. Motor learning is the understanding of acquisition or modification of movement. So meaning, may nagbabago na sa iyong kakayahan or skill. For example, you are playing a piano. Then hindi mo pa alam paano gamitin ito. At sa pagdating ng araw, malalaman mo na kung paano ito gamitin at paano ito i-handle. At saka, sa tulong ng motor learning is dito natin malalaman kung mayroon ba itong pagbabago. So, as applied to patients, motor learning involves the reacquisition of previously learned movement skills that are lost due to pathology or sensory motor or cognitive impairments. This process is often referred to as recreative function. It means to help us to understand how we learn skills so the skills becomes automatic. So let's proceed of differentiate motor learning and learning. So learning is a process of acquiring knowledge about the world. Motor learning is a set of process associated with practice leading to a relatively permanent change in the capacity for skilled actions. So ang difference sa kanila is ang learning is is a process of acquiring new understanding, knowledge, and also skill. So, ang motor learning is a process, is a skilled task with a goal, is kanang naa siya goal nga gina-reach. For example, like what I've said earlier, yung pag-play ng piano. In the first place, hindi niya pa alam kung paano gamitin. Sa pagtulong ng motor learning is alam na niya paano ito gamitin. And also, naa siya changes. Next is concept of motor learning. So first, we have a learning is a process of acquiring the capacity for skilled action. Learning results from experience or practice. Learning cannot be measured or observed directly. And lastly, learning produces relatively permanent changes in behavior. Short-term change is not learning. So let's proceed of forms of motor learning. So there are two forms of motor learning which are two forms of long-term memory which are the explicit and implicit. Explicit is declarative, implicit is non-declarative. So the implicit is there are facts and events. There are medial temporal lobe areas, sensory association cortex, hippocampus. So the implicit is not there are three categories. There are non-associative learning, associative learning, and also procedural. So non-associative learning is habituation and sensitization. It is reflects by pathways. The associative learning is classical and operant conditioning. There are emotional responses and skeletal musculature. So for example of emotional responses, it is amygdala. And the example of skeletal musculature, it is the cerebellum, deep cerebellar nuclei, premotor cortex. Let's proceed to procedural. There are skills and habits. For example, there is striatum and other motor areas, cerebellum, etc. So next,
The theories of motor learning. First is Adam's closed loop theory. In this theory, in motor learning, sensory feedback from the ongoing movements is compared with the stored memory of the intended movement. Memory trace selects and initiates a movement. Perceptual trace built up over practice is the internal reference of correctness. Second is the Schmidt schema theory. This emphasizes open loop control processes and generalized motor control. Schema is a generalized set of rules for producing movements that can be applied to a variety of contexts, equivalent to motor programming theory of motor control. Under Schmidt schema theory, there are four information stored in short-term memory after a movement is produced. Number 1, initial movement conditions. For example, body position, weight of an object, and step height. Number 2, parameters. Parameters of a generalized motor program. Number 3, outcome of the movement in terms of knowledge and results. Number 4, intrinsic sensory feedback of the movement. On the other hand, there are two schemas that was converted in information stored of short-term memory. Number 1, the recall schema. This selects a specific response and contains rules for producing a movement. Number 2, recognition schema, evaluates the response correctness and informs the learner about the errors of the movement. The last theory is the ecological theory. The learning involves the exploration of perceptual and motor workspace. Number 1, identify critical perceptual variables, for example, regulatory cues. Number 2, explore the optimal or most efficient movements for the task. And number 3, incorporate the relevant perceptual cues and optimal movement strategies for a specific task.
FITTS and Posner three-stage model. Autonomous stage. Autonomous stage is when process and learning stop, when your mind stops thinking about the movement and switches the movement or skill over to an automatic response. This is when progress in this skill is halted. It is possible for the body to make this switch way too early, and many of us do this. Implications. System's three-stage model. Learners initially restrict degrees of freedom DOF and gradually release the DOF as the task is learned and the skills improve. Novice stage, advanced stage, and expert stage. Implication for Posner three-stage model. Motor learning probably occurs in stages. Activities of the patient are different in the different stages. Activities of the therapist should be different in the different stages. System's three-stage model. Learners initially restrict degrees of freedom DOF and gradually release the DOF as the task is learned and the skills improve. Novice stage. Simplify movement by constraining joints and DOF. Example, muscles construction. Less energy efficient. Advanced stage. It gradual release of additional DOF and more adaptive to different contexts. Expert stage. All DOF released, efficient and coordinated movements, and exploit the mechanical and inertial properties of the limbs and the environment.
Gentile's two-stage model emphasizes the goal of the learner and the influence of task and environmental characteristics on obtaining that goal. So the first stage is getting the idea of the movement. Learner tries to develop an understanding of the movement requirements, and learners also must discriminate between regulatory and non-regulatory conditions. So the regulatory conditions is environmental conditions necessary to successfully perform the task. So the regulatory movement is need ni mo mabalaan ang conditions sa environment before mabuhat ang task or before buhaton ng task. The non-regulatory movement is the factors that are not inherently related to producing the motor response. Therefore, learner must use selective attention to attend to relevant information while ignoring irrelevant information. So, we have the second stage of Gentiles model. We have fixation and diversification. So, fixation is a closed skills that perform in a fixed, stable environment, while the diversification is an open skill that perform in an unpredictable environment.
Okay, so I will define what is practice condition of mass versus distributed practice and random versus block practice and transfer. In mass versus distributed practice schedule, mass practice describes a thing that is done less frequently, but for a large period of time. Distributed practice describes a more spaced out method where you study in interval over time. Next is random versus block practice. Random practice multiple tasks in 15 minutes. Result in better learning than block practice. Practice one task in 15 minutes. In healthy adults but not necessarily patients. Next is transfer. Amount of transfer is determined by the similarity between the two tasks or the two environments. The more closely the practice environment resembles those in the performance environment, the better the transfer.
Whole versus part task practice. Task specificity says the best practice is the task itself. If utilizing a part technique, the part, for example, is hip and knee flexion, extension must be a naturally occurring component of the whole. Example is walking. Constant versus variable practice. Usually variable practice that walk at different speeds results in better learning outcomes than constant practice that walk at the same speed in health adults. Mental practice. The same neural circuits producing the movement are also active during mental practice, can produce large positive effects on performance of the task. Rawlings, 1972. Physical and mental practice produces the best learning outcome.